Yesterday we have seen the rules of drawing ray diagrams for a concave mirror. There are four rays, incident rays. First one is traveling parallel to principal axis, and the second one is passing through focus, and the third one is passing through center of curvature, and the fourth one is striking the mirror at P. Now we are going to see the positions of the images for different positions of the objects. Positions of the object at different places, respective positions of the images for a concave mirror. In the first position, the light rays are traveling from the object. Object is nothing but any substance which is placed in front of mirror is known as object. The light rays are coming from the object, traveling parallel to principal axis and reflecting from focus. This is according to the first rule. Now let us take some more rays. Here we have taken the second incident ray, which is again traveling parallel to principal axis and reflecting from focus. Here we have considered only the rays which are traveling parallel to principal axis. Two rays, one above the principal axis and the other below the principal axis. However, they may be, but they are parallel to principal axis. So after striking the mirror, they meet at focus. So here light rays are converging at a point. That point is focus. So parallel rays are converging, that's why concave mirror is also known as a converging mirror. This is the first position. If we place a screen near F, we can catch the image on the screen. As the image can be caught on the screen, this is real and inverted image. And the size of the image will be very small, which we call as point sized image. So here altogether we get information about object, image, size and nature. The object is placed at infinity, the image is formed at focus small f, and the size of the image is point sized very small, and the nature of the image is real image. As it is real, it is inverted. Now let us consider different distances. If the focus is at 15 centimeters, center of curvature is double the focus, it is at 30 centimeters. If we consider a distance beyond C, it will be 3 times the focus, that is 45 centimeters, and 4 times the focus is 60 centimeters. From this distance to infinity, we consider infinite distance. Beyond 60 and beyond is considered as infinite distance. Here we consider parallel ray, which is traveling parallel to principal axis from the object and passing through focus. In this case, we consider object beyond C. In the previous case, the object is at infinity. Now the object is brought a bit closer to the mirror, that is beyond C distance, that is at 45 centimeters. This 45 centimeters is not the fixed measurement. This is for understanding we have considered the distance. Now the second ray is traveling through focus. According to the rules, it should reflect parallel to principal axis. Now the reflected ray is traveling parallel to principal axis. We can observe both the reflected rays are meeting at a point. This is the first reflected ray and this is the second reflected ray. These two are meeting at a point here. This point is in between focus and center of curvature. If we move the screen front and back, The image can be caught exactly at this position in between focus and center of curvature. Means this distance will be between 15 to 30 centimeters. Arrow headed down represents inverted image. So here the image is formed between F and C, and the image is between F and C, and the image is real and inverted image, and we can see the size is very small. In previous case it is a very small, which is called as point size. Here the size is a little bigger comparatively. We call the size as points. Before it is point size and it is called as diminished image. So if the object is beyond C, the image is formed between F and C, and the size is diminished image, and the nature of the image will be real and inverted.